Hello, fellow engineers. Today, we aren't going to cover RAG basics or how to call APIs. We're diving straight into a hardcore topic, how to make your RAG system actually survive in a production environment, to the point where your business stakeholders can confidently make decisions based on its outputs. When optimizing RAG, many teams spend 90% of their effort on the generation side, endlessly tweaking the LLM. But the real world data tells us this. If the retrieved data is garbage, using a more powerful model just gives you better packaged garbage. The real bottleneck is absolutely not the LLM. Let's look at some real data. 70% of RAG quality comes down to retrieval. Business users are afraid to use it because your AI only provides conclusions, not the evidence behind them. What's worse, once an error occurs, the lack of system observability means your team doesn't even know what to fix, bringing the project to a dead halt. To break this deadlock, we have to re-examine the core RAG pipeline. Next, we're going to tear RAG apart to see exactly what separates a production-grade system from a toy. Let me give you a very straightforward example. A salesperson asks about the refund policy. A toy RAG just says, yes, you can. But can you make a real business decision based on that? No. A production-grade RAG has to tell you what rule is this based on, what are the prerequisites, and what are the exceptions. All three elements are non-negotiable. Here is a standard RAG pipeline. On the left is data preparation, ingestion, chunking, and vectorization. On the right is runtime retrieval and generation. Sounds simple, right? But the devil is entirely in the details. The 7 best practices we're going to cover next are designed to completely overhaul this pipeline. Please engrave this sentence into your minds. Stop worshipping God-tier prompts. If your retrieval recall doesn't pull the prerequisites and exceptions alongside the main context, the LLM will absolutely hallucinate out of context. Data structuring will always trump prompt engineering. So how exactly should we do this? We've summarized 7 best practices that determine the success or failure of a RAG system. Every single one of them is a hard-learned lesson, bought with countless production crashes. Step 1 is document chunking. Are you still using LangChain's default fixed length chunking? That's the laziest approach. You slice it down the middle. The subject ends up in the previous chunk, the predicate in the next, and after vectorization, the semantics are completely shattered. You must switch to semantic or hierarchical chunking to ensure the information fed to the LLM is complete. The answer is B. If you chunk by fixed word count and the sentence gets cut in half, its vector representation will completely deviate from its original meaning. Once you fail to retrieve it, no matter how hard the LLM tries later, it's useless. If you didn't get this right, you need to listen very closely to the upcoming retrieval strategies. The second and third practices invest heavily in embedding quality, and you absolutely must implement hybrid search. Vector search is great at understanding semantics, but it's terrible at matching proper nouns or product models. You have to combine vector search with traditional BM25 keyword search, plus metadata filtering, to guarantee your recall rate. The fourth practice is introducing a re-ranking layer. The initial retrieval from the vector database is fast, but lacks precision. We typically recall 50 chunks first, then use a cross-encoder to re-rank them, and finally pick only the top 3 to 5 most relevant ones to feed to the LLM. This is the most cost-effective move to boost accuracy. The fifth practice is writing retrieval-aware prompts. Don't just tell the LLM to answer based on the context below. You have to set ironclad rules in the prompt. It must include prerequisites. It must point out contradictions. If it can't find the answer, it must say it doesn't know. You absolutely cannot let it use its pre-trained knowledge to fill in the blanks. The final 2 practices are all about iteration. From day 1 of launch, you must implement tracking to collect user thumbs up and down. Also, whatever you do, don't test the system with perfect questions you made up yourself. Real user queries are full of typos, corporate jargon, and logically messy compound sentences. Your system has to survive in this real-world noise. Once you've mastered the foundational 7 practices, your system has reached a passing grade. Next, we're heading into the deep end. to see what advanced architectural optimizations we can implement to tackle extremely complex business scenarios. User questions are often extremely brief or complex. This requires query transformation. For example, when a user asks for a product comparison, the system should automatically break the question down into two independent queries. Or by using high DE, we let the LLM pretend to answer first and then use the vector of that fake answer to fish out real data from the database. This drastically improves the hit rate for short questions. Next is intelligent routing. Research shows that 63% of queries are actually very simple and can be handled by standard RAG. Only when we encounter extremely complex cross-document reasoning do we route it to an expensive LLM that supports ultra-long contexts. This is the self-route architecture, which drastically cuts API costs without compromising intelligence. For the geekier teams, you need to understand the RAG stack blueprint. Simply put, it breaks RAG down into an intermediate representation layer, a cost model, and a plan exploration module. This allows you to find that perfect sweet spot between millisecond level latency, token costs, and answer quality. The system is built, but how do you prove it actually works? You can't evaluate AI based on gut feeling. We need to introduce quantitative evaluation frameworks and the right development tools. When it comes to framework selection, many people struggle between LangChain and Llama Index. Honestly, if you're building an agent that calls tools and plans tasks on its own, choose LangChain. If your absolute focus is document Q&A, data indexing, and advanced retrieval strategies, Llama Index is definitively the better choice. The current industry gold standard for evaluating RAG is the RAGAS framework. Focus on three metrics: faithfulness, meaning does the answer have verified sources? Answer relevance, meaning are we actually answering the question asked? And the context relevance, meaning how much fluff is in the data you pull back. The more fluff, the easier it is for the model to be led astray. The answer is B. Long context models are undeniably powerful, but they're expensive and slow. For over 60% of routine questions, a well-built RAG architecture gives you the exact same answer as an expensive long context model. Allocating your best resources where they're needed most is the hallmark of a senior architect. The theory is out of the way, so let's look at some real code. How do hybrid search and metadata filtering actually get implemented in a production environment? This is the core logic for hybrid search combined with re-ranking. First, pull 30 records each using vectors and BM25. Then merge and deduplicate. After that, pair the question with every single document and send them to the cross-encoder for rescoring. Finally, you just take the top 5 highest scoring documents. This is what we call two-stage retrieval. There is a massive pitfall here. Absolutely never shove all your business rules into the vector database as plain text. Hard rules like departmental permissions or document expiration dates must be stored as metadata. At retrieval time, use a filter directly to screen out expired or unauthorized documents. This is the most effective firewall to prevent the AI from spouting nonsense. Finally, don't forget the infrastructure. The moment your RAG goes live, it's going to hit permission control issues. Regular employees absolutely cannot be allowed to search the financial data that a VP can access. Then there's token cost billing and API timeouts caused by re-ranking. These engineering challenges are often way more of a headache than tuning the model. At this point, the complete engineering deployment framework for RAG is fully mapped out. Let's do a quick recap of the hardcore terminology we covered today using a single slide. A quick rundown: dense and sparse are the foundation of hybrid search. Cross-encoder is the sharpest tool for re-ranking. High DE is the query transformation magic for handling short questions. And RAGAS is the quantitative ruler you use to measure how good your system is. These four terms are the absolute core jargon for advanced RAG discussions. If you only remember one sentence from today, I want it to be this: what determines RAG's success is always how the data is organized before it reaches the LLM. Stop worshipping prompts. Go back, thoroughly organize your knowledge base, and clearly structure your prerequisites, bases, and exceptions. Finally, here is an action checklist for you. Go back today, stop fixed chunking, add hybrid search, introduce re-ranking, and get your logging system set up. Rebuild to this standard, and your RAG will absolutely walk out of the lab and become a powerful weapon on your business lines. Thanks for watching, and see you next time.